Hello, everybody. How's it going? Good to see SE Woods and Voxel Riffs. It was supposed to be Odin time, but unfortunately, I was trying to get it building just a second ago, and it's just failing. And the only binaries he has are for AMD 64, so it's C time instead. We'll try Odin again the next time. But SE Woods, Friday stream. Finally decided to full-time Twitch YouTuber. I knew it. Not quite. So today I just have the day off to take a day off. So tomorrow I'm going to be busy and stuff too. So I figured do a streaming this morning, and then that way I don't have to worry about tomorrow. But hope you guys are all doing all right. Today we are going to be looking at 6502, running an emulator, and eventually I want to be able to run like a NES emulator too. So I might modify it a bit to get exact specification there. But the whole purpose of this is mainly to get experience writing like an IDE, a debugger for some assembly, and then to eventually be able to build games in this assembly, because I want to try my hand at writing games like they did in the 80s. So I think 80s, 90s is when 6502 was. That was like NES time, right? NES was 80s, 90s? I don't know. So I was not born then, unfortunately. But yeah, so that's the plan. Today, we are going to be taking a look at this. First of all, let me turn on my mouse capture so that you guys can see what I'm doing. Let's go here and there. Wrong one. I always click the wrong thing. For some reason, I got to have both these in the same place, I think. And one of them works, the other does not. But yeah, so this is, just want to give a update on how this is going and stuff too. I had to work on animation groups to get axis working. So this is an axis. It's got a lot of settings. You can change like how big the tick width is and everything. I'll put that back to 75. You can change the increment. So like if I change this to increment in 2, you can see we get 0, 2, 4, 6, 8. You can turn off the labels so you can just get the ticks, or you can turn them back on where you get numbers. This is a bit messed up at the moment. You can see the texture doesn't look completely right. But the hardest part about getting all this right was animation groups. So technically, this is an animation group. This is one SVG object. This is one SVG object. Each of these numbers is one SVG object. So I had to get some extra functionality in there in order to get this to work right. And I wonder if I might do like a lagged animation type thing where all of these start at slightly different offsets. It looks kind of cool, I think, kind of going all at once, but we'll see. Shouldn't 0, 0 be at the center? 0, 1, 2, 3, 4. It should. I could change that if I change the Y range. So the only reason it's not is because of the way I have this. So if I change this -10 to 10, or I guess -5 to 5 would probably be a little bit better. But yeah, so we get -5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5. So yeah, I have to tweak some things just with the settings and stuff to get it to, where you can move the axes or whatever, or change where the center is and stuff. So right now I just have it centering automatically. But yeah, it's going pretty good with this so far. I'm still happy with the way it's going. And of course you can always change like the color. So we can go ahead and do that. And then the fill color on the letters if you wanted to as well. So I'm pretty happy with it so far. We'll see if I can continue making some progress. I'm at like the final steps now. And as you can see, I still have to fix this because it did not reinitialize it properly. But I still have this is a good point for me now, because now I can create like more 3D objects and stuff, and it should all be good. So I'm happy with the way that's going. But anyways, today is not about this. Today is about writing a 6502 emulator. I've been looking into it a little bit. So I followed a small tutorial. It was like this one, I think, Easy 6502. I didn't really like it that much. It kind of just like gave you the instructions. It was like, hey, here's the instructions. And then it was like, okay, final project. We're going to build Snake. And then it just gave you the code and walked through it, which I didn't really like. I'd prefer to write it myself. So once we get like a basic emulator up and running, I think that's when I'm going to go ahead and just write it myself. And one other thing I wanted to do too, just very quickly, is like NES 6502 example. Mario Bros. I want to take a look at this because let's see. It looks like some flavors of 6502 allow you to do like kind of more descriptive names than just using like A, X, and Y, which is the accumulator register, and then the X and Y registers. So I'm just kind of curious if there is... Nope, that's the binary. What about this guy? Okay, so like, yeah, you can see that he's using like raw hex here, but then he has this descriptor, I think is what that is, .db. And I'm just curious what those are. Okay, yeah, and then you can see as PPU control register 1, control register 2, control reg, sprite channel. Okay, yeah, so it looks like you can just do kind of like, these look like variables, but really what these are just like constants that basically just get substituted, right? So this would just substitute this hex 0700 wherever it sees that. I'm wondering what dB is though, because that is interesting. And this looks a little bit more complicated. So there's some things I'm gonna have to look into, because like just building the actual processor is not gonna be quite enough. We're gonna have to build an assembler too to actually like translate this into proper bytecode that we can then interpret. But yeah, for the most part, this is what 6502 looks like. So it's going to be fun. Oh, I think that was just a label is what this was. And then .db. Yeah, I'm interested in what that is. But anyways, yeah. So it's going to be pretty cool. And SE Woods, would you mind quickly tell what an emulator is? I only have a vague idea. So an emulator is basically... back in the day, they had 6502 processors, which were the actual hardware. And so if you had an NES, you actually had your 6502 processor that would run 6502 bytecode, which is just binary. I guess not bytecode, it is binary. So you would just run that and the processor would take that and like literally translate it and dispatch all the instructions and compute. But an emulator is doing the same thing in software. So instead of us building a chip, what we're going to do is, since modern computers are so powerful, you don't even need like dedicated hardware for this, right? We can go ahead and code a whole program that basically emulates, right? It's copying. It's like a fake version of this. And this is in French, I just realized. I think that's French. I have no idea. This might be a different language, but that's funny. No, I think that might be Spanish. No, I don't know. But anyways, so we're going to emulate it. And basically what that means is we'll have some program that goes and it reads a file, right? And so it's going to read that binary, turn it into an instruction, and then basically interpret it through the program, and then do what it would have done on the actual hardware. So it's kind of a vague idea of what the emulator is. Once we get into it, it should hopefully become a little bit more clear, and especially once we start doing some of the more simple things. But yeah, I've never, like, I know Java X9 has a video on this, which I may reference from time to time, but I have not watched this. I don't know how it works. I'm just going to kind of go at it using the instruction set, and then we're going to see how this goes. So yeah, but I think that'll be fun. So first step for this is we're going to go into here, dev, and I guess, okay, so going to use C API, which means that all of my header files are going to be pure C. Yes, pure C. And then implementation can have C++. So that means like, yeah, we'll see what that means. But I don't want to go full C because I do still want to use standard library for some things. I don't know. Maybe I'll change my mind halfway through and we will go full C, but there might be a little bit of a mix. So, okay, so let's go ahead and we're going to create a new folder here, if I can. And we're going to call this emulator 6502. And I guess the first step is creating a repository for this. No, you've been bamboozled. Yes, I apologize. I'm not quite ready. I really wanted to do this in Odin and like use this as a chance to learn Odin, but since it wasn't working properly, looks like we're gonna just go with good old C, at least for the headers and stuff. It should make compilation faster though, and it should make the API simpler, which I think will be good because that means I won't be able to use like function overloading or operator overloading, anything like that, unless it's like actually in the implementation files, which I do think will be nice. So yeah. an emulator for some 6502 code. Okay, let's go. So we're gonna just go ahead and create this. I guess I'll do that just so that we have that. Okay, so copy that. Also, if my typing is slightly slower, I got a new keyboard. If you can see that, it's fancy. It has RGB. It is the most expensive keyboard I've ever bought because my old keyboard broke and I figured why not. So if my typing is weird or whatever today, that is why. But really enjoy the keyboard so far. It's just a little bit different than I'm used to. Okay, so we got that. Let's go into here. Let's do that. Cool, we got that. I'm just gonna drag this stuff up to here and we're gonna delete that. Okay, so we've got this. What's our format gonna look like? We're gonna have source, not like that. Actually, I'm probably gonna do, let's do emulator, and then we're gonna have a source, and we're gonna have a include. And we can go based on that some other time. Then we're gonna have vendor. Yeah, I'm probably gonna use pre-make for this. Debating what I want to add just yet. Don't want to go and add a bunch of stuff. Like, I don't want to add GLFW and everything, especially since we're going to do other stuff. Did I spill coffee on the old one? No. It just started breaking. Like, I'd be typing and then it would do double key presses when I was just typing once, and it was very annoying. And so I went, took it apart, cleaned it up with some rubbing alcohol, whatnot, and cleaned it up, dried it out. Tried it again and it still wasn't working, so I was like, okay, it's trashed. It was like $20 keyboard before, so should have expected it. It had been like 2.5, 3 years, so it was getting older, I guess. But yeah. And VoxRiffs, what STL stuff do I need? That's what we will find out. I'm guessing I'll probably be using like hash maps and vectors, which aren't the hardest to implement, but I just don't feel like implementing them quite yet. So yeah. And as you was going with the neon lighting, I'm expecting Fast and Furious keyboard pounding. Uh-oh, that's not what I was hoping to. And now I got the higher expectations. Okay, so I'm going to go ahead and create a new file here. We're just going to call this pre-make. And I don't think you need... Do you do like a .lua? I don't think you need a file extension there. Let me just double check from one of my other repositories. We're going to steal, and then I'm going to kind of go based off that. So we're going to go ahead and just copy this pre-make. Okay, so you are pre-make 5.lua. We're going to copy that, paste it into here, delete that, and then I'm just going to modify it. We are going to go into here, and I'm also going to steal that. So we have pre-make binaries. This is how I do stuff now because it's easier than just trying to remember everything and do it all from scratch. I mean, it probably isn't, but okay. And then in here, we're just going to have a file main dot. I'm really tempted. I don't know. Maybe we should start with C. We'll start with pure C. And then if I get to a point where I'm like, okay, it would be helpful to have C++, we'll add C++ files as necessary. So we'll start with this and we'll see how it goes. And then I can change it up as we go along. This will be good. So it's going to be a mix, a proper mix of C and C++. And as Woods, the Z on my laptop always gets stuck. Never fun. And VoxRiffs, you have a generic hash table in your base layer. You could just copy that, but it doesn't matter. We'll see. Maybe I will. Okay, we'll see about that. I am going to use my CPP utils library because I think it is C compatible. I might make it C compatible if it's not already, but it is nice to have. So let's open this with code. VS Code, that is. Okay. Let's go ahead and change this. This is going to be emulator 6502. Okay, that's fine with me. I'm going to change this to emulator 6502. That's our output directory. And this once again. Okay, so we're going to do this. I've never done a C project in pre-make. So let's go ahead, pre-make C configuration. Okay, so we have configuration. Yep. Let's see. What is the... So we have language. Let's look at language real quick. Okay, so we can just do C, built-in, always available. Cool. All right, we're going full C. We'll see how this goes. No pun intended. Okay, and then do we have C dialect is what I'm wondering. C dialect. We do. Okay. So C dialect, we're going to go with... I'm going to go with C17. I'm wondering because I think C11 has the like structure destructuring thing where you can do like the dot syntax. I'm not sure when that was added. We're just going to go with C17. We'll take the latest version. Doesn't matter too much. Actually, oh man. Okay. If we do decide to switch back out of C, that might pose a problem though. So we're committing now. Okay, so we are committing C17. I'd have to go and like swap things into static libraries or DLLs if we want to have C++ now. But it is what it is. We'll see how this goes. Okay, static runtime is on. Cool. Emulator 6502. So we'll take that. We will take that, and I will just go ahead. Get rid of all this stuff. I'm probably gonna just keep some of this stuff in here because we're gonna most likely be using some of this stuff. So let's go ahead and do that. And I can never remember how to do this in Visual Studio Code. This should be fine. Okay, so we're gonna comment that stuff out and that for now, and then I may add that later. Okay, this is gonna be that, no need to worry about that, or that. Okay, so nothing special in there. Release, nope, nothing in here. Okay, Windows. I'm not sure why I add this. We're gonna remove that because that's just something that's been copied, pasted around for a long time. We're gonna keep this stuff and then I'm just gonna comment it out for now. But we do not need this. Okay. I guess that means we could comment out this whole thing. So do that. Defines. C runtime, no warnings. Let's leave the warnings on for now, and then I'll change that in the future if we want to. Okay, so we can do that. Libdars. Yeah, we don't need that. We are not linking. We might want to link to some of these Win32. No, we should be fine. Okay. So debug, we turn on debug runtime, release, and we define that, and that should be good. Cool. So let's see how this goes. And that should be it. We now have a configuration. If I go and, wait, that's the last thing that I needed to, that I was forgetting. Okay, let's add my build.bat file too, because I do like that. Where is that? Grab this somewhere up here. There we go. Man, the lengths you have to go to just to set up a basic project. It's pretty annoying. I hear CMake is easier, and if Sam was here, he'd be telling me to switch right now. I will eventually have to, but for now, we're just going to leave it as is. Okay, so we're just going to have this. It's a very simple build. Okay, let's go build VS 2022. C17, invalid value. Okay, maybe I can't capitalize that. Pre-make. Let's try that. No, still invalid value. Do I have a... Let's download the latest version of pre-make. Getting started. Let's go here. Download Windows. Okay, so just to show you guys what I'm doing here, let's go to here, or not here, let's go here, dev, And I'm just going to download directly to there. Let's delete that, delete that. Okay. And let's go and just pull this out. See if this works. It might just be because of VS 2022. Oh wait, do I have that as CPP dialect still? That's what's wrong. Yeah, that should be C dialect. Okay, there we go. And now I have to capitalize again. No? Is it not called C dialect? Okay, C dialect, C17. That's weird. What if I did... No. Okay, let's try C11. Okay, I guess we're doing C11 then, because is there such thing as C17? Yeah, I don't know. Okay, let's just check chat real quick. Do I really need pre-make though? Probably not. Control Alt Shift arrow keys. Control Alt Shift arrow keys. It is. Thank you. I always forget because in Visual Studio it's a little bit different. You're telling me to switch to a batch file now. We'll leave it pre-make for now because I'm wondering if I'm going to have to add extra things in. Okay, anyways though, so that should be that. Let's go back into here. Now we have a project file. I'm going to open this up. And we should have our, let's change our view here to this. We have main.c. And if we go int main, let's go ahead and include, I wonder why I'm not getting IntelliSense here. Well, actually, never mind. That does make sense. Don't have any files. Okay, is it stdio.h? I think that's it. Printf. C has some subtle differences, so this may take me a little bit to get used to. Let's see. Okay, unable to start program. Cannot find this file specified. Okay, what did we do wrong here? So we got bin. And we just got nothing. Did this do anything? Okay, so we did do something there. Is this not included? That's what I'm guessing. Let's go back into here. I'm wondering if these numbers, this is why I was hesitating to put 6502, because I don't know if the numbers are going to mess with this. Let's also just change this. That was for other reasons. Okay. So you have source /star_star.c and we have include /star_star.h, but it looks like it's not including that. Oh, it's because this is emulator, not emulator 6502. Okay. So if we do that, cancel save. And we change this. Okay, now if we rebuild, we should get all of our files included and we should be fine. So let's delete that. And now if we go back into here, reload. Okay, and now that's included. Yeah, so we were just compiling nothing. Cool, so hello world works. That's great. Now, next thing I want to do is I would like to use my CPP utils library, but that would probably require some changes, which is kind of annoying. Git link, yep, I'll send that to you guys real quick. There you go. It's got absolutely nothing right now, but this is it so far. So I'm wondering, I think I should probably modify my CPP utils library to actually be C only so that I can actually do this. CGO clan, you should use some bot where if you type not git, you can get the link or something. That would be cool. That would be cool. I have to play around with like Twitch features that I haven't done before. It would be nice to do that eventually. Very quickly, what I'm going to do is we're going to go into here. And I'm going to add like some sort of compiler definition for pure C, because right now this has just a couple things that are not pure C. which are, so C stood int, I think that's C++ library. Usually the C libraries have .h. Yeah. Let's just double check that real quick. C stood int. Yeah, this is C++ 11. So this was originally studint.h. Okay, so first of all, let's change this to studint.h and studdef.h. Okay, so that's an easy way too. If you're ever wondering whether you have a C++ or a C library, if it has .h, it's C library. If it has no .h, it's C++, at least as far as I know. They don't have the C prefix either. Wait. I'm gonna be back about 10 minutes. Maybe we should try to get the Discord bot before Twitch bot. Yeah, that's true too. And they don't have the C prefix either. I'm not sure what you mean. Oh, they don't have C before. Yeah, that makes sense, because if it's a C, why would you put C library? Yeah, that makes sense. Okay, let's go. I have a couple more things in here too, though, that are, yeah. So, okay, this is kind of mutex vector memory. So until I learn how to do multi-threading in C, we're gonna ignore mutexes for our C implementations. I don't want to remove this though. I want to just change it up. So we're gonna add a processor that's hash if not defined pure C, or I guess C impl, and if. Okay, so that should stay in there for now. Let's go into, now we're doing a couple of things. We're doing like 2 projects here. Let's go open this with code real quick, because now I gotta change a couple things. So yeah. Okay, what I'm gonna do is we're gonna go up here for now, and then this will be something you can turn on later. So define C impl. I guess, I don't know, no CPP. That makes more sense. So no CPP means no C++. So if not defined, no C++, else what are we gonna do? So I have memory, vector, and mutex there. Hash include, I still need memory stuff. So we'll do memory.h, vector and mutex. I'm gonna put it to do implement C version of, we're just gonna say mutex. For vector, I'm just gonna do some simple stuff. Studio.h, that's fine. So we got studarg.h. This is for Linux. Is it? No. Okay, so this is all C libraries. Oh no, yeah, this is for Linux. Or is it? Wait a second. If not defined Linux. And I have that commented out. So I guess I'm not using that anymore. So we'll get rid of that. Okay, whatever. So we got studio, arg, lib, chrono. We can't use that. So this is going to move up to no CPP. Thread. Do we have a thread.h? We do not. Okay. That's also going to move up here. Algorithm, array, C string. Yeah, all this stuff is going to move up there. Okay, so that's all. And I don't think, okay, I'm also going to remove this because that's a 2022 feature, C++ 2022. And that was annoying me because it kept giving me complaints. Okay, so these are C version stuff, which we can use. Okay, yeah, that's fine. Comment includes. Okay, so then if we got Win32, we include C runtime and Windows. That's fine. Let me just check chat real quick. I made my own version of CPP utils in C with minimal stuff like logging, assertions, memory management types, arrays, and other stuff, but still like so minimal. Nice, yeah. I've noticed that when you were posting it in the deep Discord, and it looked pretty cool. So it's fun stuff. And Voxstars, you can use C++ to see if you're compiling with CPP. Just discovered that auto type in C works like auto in C. Huh. Will this finally be an NES emulator? Hopefully, eventually. Johnny123TW, thank you for chatting too. So right now what I'm doing is I'm modifying my C++ utils library to support C, since I plan on writing this in C, but we're going to start with 6502, and then I am going to modify it following whatever this documentation is. modified different things to make sure that it emulates NES as closely as I can. But for now, the plan is just to like create a debugger and stuff, because why not? It's fun, right? Fun stuff. So that's the plans. And let's change this. I like what you were saying. Voxriffs, you said CPP util or C++? C++, like that. If not, define C++. Yeah. So this is defined is what I'm guessing that's saying. If I were to change this to... makes sense. Okay. So instead of that, though, what we're... Well, okay. What we can do is we can define this to be not defined C++. No CPP is not defined C++. Does that make sense? Yeah. That's not defined. Then no CPP. Okay, yeah, we're going to do that. That way, if you want, you can, and we're also going to do hash if not defined, no CPP. Whoops. Okay, so we're going to do something like this. That way, you can always override it if you want to, so that while we're testing, we can override it. So even though C++ is defined for me, we're going to override it for now. And then we'll just go up here. Change that. Okay, so sorry for all that, but we have to do this real quickly. Okay, anyways, so C type, we need to do something like that. Type def struct debug memory allocation. And we cannot, okay, so we need a C safe version. Hash if define, I don't like this double negative. If not defined, no CPP. Let's change this to if defined, use CPP. So let's change that to that. So if defined, wait a second. Okay, this isn't going to quite work. That should work. Okay. And then instead of doing if defined, we're just going to change up what I'm doing down here. So if where was that? Okay, stood int, that's fine. Here we go. That's better. Okay. That's better. So if use CPP, we do that. Else, we're going to say type def. I think this is how you do a C declaration, right? Debug memory allocation. And this would be debug memory allocation. Kind of that double declaration. File allocator. Line references and size t memory size. Okay. We'll do that, and then I'm going to define just a helper function. Void, or I guess bool. Okay, and this is, so if I'm also doing C, we probably want to namespace this. So, So I'm going to do like a Sean Barrett thing. GMA, that's my initials. So we're going to do a Sean Barrett, like STB, right? Sean whatever Barrett. GMA for my initials to namespace this stuff. And this is going to be CPP for CPP utils. CPU? CU. CPP utils? C utils? Yeah, we'll do CU. So GMA underscore CU. I don't know, double namespace isn't very nice. We're just going to leave it this, okay? So we'll just leave it like that. This way we can say GMA. Okay, so this is going to get a bit wordy. If any of you C folks out there have any better ways to do this, let me know and I'll change it up in a little bit. But for now, we're just going to leave it like this. So let me see, GMA A B. Gonna do that. Make those const. Oh, and I probably also want to, we'll do this and mark that static, and then I'll add the implementation down in our implementation areas. Okay, we'll fix that in a minute. Wait, is this in the implementation? Oh, this is in the implementation. Okay, so if that's the case, we can just do this. And then just return, same thing up here. A memory equals B memory. Okay. So we've got all this. And the reason I'm doing it this way too is because I have other, like, multiple libraries using this, and they all use C++. So I don't want to ruin those, which is why I'm segregating everything like this. And then I'll change it in the future so that this is C only once I get the mutexes and stuff working properly. But I don't want to break my other libraries for the moment. So we're just going to do it this way. Hash if use CPP. We'll do all this, okay? Hash else. We're going to have our allocations. Okay. Rethinking this again. Why is it called C++ in your define? Thank you, that was wrong. That's what it should be. Thank you. Rethinking this again real quickly. So this is Win32. This is memory implementation. Let's do if use CPP. So this is for our C++ Win32. And then I'm just going to do copy all of this stuff. And then we're going to do a separate one. So first of all, let's just do this. Get rid of that. Okay. So we're just going to have this. This is our C++ implementation. That's our logging implementation. Okay, so then we're going to do else. And if, right? This is going to be our C implementation. So CPP Win32 implementation. Let's call that end. Okay, end C11 implementation. Okay. This way it's just a little bit more consolidated. So do that. Let's call it that. Copy this. And why am I going through all this trouble too? I should probably say something like that. The reason I'm going through all this trouble is because this library has some very nice memory tracking things that I'd like to keep for our C implementation. But if I want to compile this into my C library, then I'm going to have to make sure that works properly. Okay, so let's keep going. We've got this. This is our C implementation. And so then what I'm going to do is I'm just going to copy the C++ implementation here, which goes up to here, and then we're just going to modify things as necessary. So do that. Really, these should all be statically defined because they should be in one implementation unit. It doesn't matter too much. Okay. So let's go to do implement thread safety. Going to be unsafe on multiple threads for now. Do that. These are our allocations. Track memory allocations, that's fine. And this will just be uint 8 special memory flags. C doesn't have const expert, right? Oh, I just need to change this. Does it have const expert? I don't think it does. I think they're thinking about adding that, but I don't believe it has it right now in C11 at least. Because if it does, I would change this to const expert, but yeah. Okay, so we've got that. We've got that. Allocate. Okay, so if we're tracking memory allocations, we do a few funky things. This is just going to be malloc now. Which, really, if I wanted to give like full control, I guess I should allow you to inject your own malloc. Which would be kind of cool. That's a future thing, okay? So a future thing would be cool to have like inject your own malloc, so that if you want to use like arena allocators or whatever, you could do that, and then it'll still do all your memory tracking for you and just make sure that, kind of like what Vulkan does. Might be interesting. Let's just put a to do. Might be cool to inject malloc like Vulkan. Yeah, let's keep that in there. Okay, so we've got our memory. We malloc that. We add buffer padding ×2 times size of uint8. That's just in order to add our canaries, which will tell us what's happening. So special memory flag size, let's just go ahead. This is going to be static const uint8 special memory flags size equals 8. And let's actually just int 32. Okay, we're going to do that. Copy that. I'm going to go here. Move that. Should do the same thing. Okay, that's good. Okay, so then we're going to put a to-do here. Implement thread safety for C. For now, we're not going to have any lock guards. It's all good. For now, I guess, for our C implementation. We'll fix that in the future, though. Okay, so our iterator, we want to find if we have this. So what we can do is bool allocation exists. Well, actually, let's do this. We'll implement something similar, except we'll just change it up a little bit. So we'll have a static GMA debug memory allocation star find. I guess we should call it GMA. I really don't like this long form name. Once again, if you have any recommendations for shortening these names, that might be useful. So anyways, we will do that. This takes in a allocation star element. I don't know what to call this. Value. Okay, so to do this, we're just going to say, oh, and actually we need to do this. We need to do a few things. So I have our list size, and we will have value, or I guess the thing we're searching for. Yeah, we're searching for that. And I'm going to change this to be non-const because you might want to change it. And since this is returning a non-const version, we want to make that implied. So we'll just size t equals 0 until size, or I guess I equals 0 until I is less than list size, right? If equals, we're going to give it list I, and we're going to give it the address of that. Or I guess we could just do list plus I. And B is going to be our value. If those are equal, return that. Otherwise, we return null. Not null pointer. There is no null pointer. We return null, which is 0. Okay, so that should be good. Now what we can do is we can change this. I guess we could give it a begin end thing too, but either way, it works the same. So what we can do is we can give it this, and I also need to add just a thing here. So this is turning into something that I did not expect this stream to turn into, but still fun nonetheless, at least in my opinion. So allocations length, let's call it that. And I'm going to change this too, because I don't like calling lengths size, because that can be misleading. So yeah, list length, let's just call it that. It's a bit more explicit. I feel like size can be weird because you're wondering if you need to pass that in bytes or something else. So yeah. Okay, and then we don't have auto now. So what we're going to say is GMA debug memory allocation star iterator is what we'll call it. Same thing. application find. We're going to give it our list, which is our allocations length, and our value, which is, okay, and this is where we can start using some C style stuff. So let's, first of all, we're going to say GMA debug memory allocation temp, right? So in C, you can actually do like dot, right? And then dot line equals line. Yeah, so I'm gonna change this up. Let's go ahead and, I've got this open here, right? Yeah, let's go ahead and change this real quickly to, this is for my own development. So we're gonna change this for now. Yeah, we'll change this to C dialect, C11, language is C. And does this all work out? Yeah. Yep. Okay. And then I guess what we can do here too is, well, yeah, this should work out fine. We'll leave it like this. Go into here. Do that. Now let's see if Visual Studio works with C style stuff. Oh, did I not save that? I don't think I saved that. Anyways, if we go back up here now, just to make sure this is working. If I were to remove that, this should still be... Okay, so it looks like this is defined for some reason. Are we actually using C here? Properties. Where does it show me? Yeah, let's see. Where does it show me what dialect I'm using? We've got application, general, I swear it tells you like what dialect you're using somewhere. Oh, here we go. Yeah, C++ language. We're using ISO C++ 14. Why are we using C language standard, default, legacy, MSVC? Yeah, we should be using ISO C11. That's weird. Language is C, C11. I wonder if I need to change the file to C. Like a C file extension. Let's do that real quick. Okay. Let's go. Oh, and I also need to change this to. Let's do that. Okay. And let me just change this. Rename. Okay, rename that, and let's go ahead and regenerate this stuff. Discard. Okay. It's still saying C++ is defined. That's weird. And it's still not giving me C11. Let's look this up. Pre-make. Using C11 still outputs C++. Project files. Okay, so it looks like they don't actually give it to you. So let's add this in here just to make that explicit. Let's do that. Another reason I should switch to CMake, because it actually probably does this right, is what I'm guessing. Nope, we're still getting it defined here. That is so weird. Okay, I'm going to stop messing with this for now, just so that we can actually get this developed. Can I just tell it to use C? Let's see. Like, how do I tell it? Okay, determines the C++ language standard it will enforce. It's recommended to use that version when possible. C language standard. Let's see the command line real quickly. Where is it telling us which version we're using? Okay, so we've got C11 in there. Yeah, so it's telling us to use C11. I don't get why it's still defining C++ then. That's so weird. SE Woods, do we have gamers in the chat? Any game suggestions on Xbox Game Pass, or do we only have hardcore coders here? Visual Studio when using C. Okay, so I guess Visual Studio is just stupid. So does this mean I can even use Visual Studio as a proper... Does it support C-style things? Let's see. If I go and do... Can I do dot... Can I not do this in C++? Or I mean in Visual Studio? Or am I using this wrong? Visual Studio using C style structure initialization. Okay, yeah, so I should be able to just do that. But for some reason it doesn't want... Yeah, let's see if this... Oh man, okay, so apparently they just don't want to fix this. Man, that's really annoying. So this was one of the things I was excited about to be able to use, but apparently we can't do that. Okay, I give up. We're just gonna do this, and then we're gonna change it later. So I'm gonna do that. We're gonna say this. Go down here. This is what happens when I try to start doing a bunch of new stuff without setting up my environment properly before starting a stream. Probably not the best idea. So this has been noted, and I will properly set up my environment before starting to code something like this next time. Okay, so this is allocations length. Let's just move on with our lives and fix this. So iterator equals that. If iterator equals null, then we want to put it into there. So let's go ahead and add that function. Static void GMA debug memory allocation push. Right, so this will take in GMA debug memory list length. We probably also want to pass that in as pointer because we're modifying that when we push something, right? Okay, so we're gonna give it the list, we're gonna give it the length as a pointer, and then we're gonna give it our element to push. Okay, so how do you push something? Okay, and this is one of the reasons I didn't want to do this originally, right? So this is a debugger, like this is a debug helper for memory allocations. Now, in order to track the memory allocations, what do I have to do here? I have to allocate memory. Okay, and so what happens if I allocate memory and then that memory allocation fails? Well, then all of a sudden I have a bug inside of my allocation code for my memory allocator that's never going to get detected because, yeah. So this is why I originally avoided this in the first place. So this, to do heavy testing here to make sure this is rock solid. Because otherwise this will break completely, and then the whole point of this is kind of broken if this doesn't work. SEWood, do you see the pull-up bar is gone? Got tired of looking at it? I guess so. I put it back up there every now and then. It's in the back corner over there. Sometimes I do, sometimes I don't. And they don't want to play with you, Ella. No. Yeah, I know, it's weird. We got 16 viewers, but they don't want to talk. I don't know. What's up with that? No, I'm just kidding. Okay, so we've got a little bit of a catch-22 here, but it should be fine. This isn't rocket science. It should be simple code. So basically, we are pushing, and then this is where we need like a max size. Okay, so this is where it's a little bit, we're gonna do this. We're gonna say struct GMA, we're gonna call this a list, and what we're gonna do is we're gonna have a star, this is our data, this is our length, this is what we're gonna do instead, and then size t max capacity. Okay, we're gonna change this up just a little bit. Then what we're gonna do here is instead of doing this, we're gonna take that, get rid of that. This find is gonna take this, gonna get rid of that. And we can go list length, and then this will just be list data. And this will return data plus I, and then we can return null. Okay, so just changing this up a little bit. That way we don't have to pass that, and we can do this properly. So we can say if list length plus 1 is greater than or equal to list max capacity. Now, is this going to be an off by 1 error? So if we have a list of size 10 and our max capacity is 11, and we want to add 1 to this, 10 plus 1, this is an off by 1 error. 10 plus 1 is 11, so we should be able to add it, but we want to be careful. We have 11, then 11 plus 1 is 12. That would be bad. Okay, so if that's greater, we need to reallocate our list, or I guess grow our list, right? And so if this is the case, then we'll just say realloc, give it our block, which is list data, size of this times list max capacity, which we're going to say list 2. I believe this is available in C. So we're going to increase our size by 2, or our max capacity. Then we're going to reallocate that, and we're going to say list data equals that. And we're going to cast this. even though it really makes no difference in C. And it's all good. It's Friday. People are probably tired. Exactly. Yeah. And did I say what I had to give for the keyboard? I did not. It was more expensive than I would have liked, though. So I have some friends who are into like mechanical keyboards, and this is mechanical, so it's nice. It's my first mechanical ever, and I do kind of like that. But it's not like full mechanical where they have like the super heavy key clackers or whatever. These ones are a little bit quieter, which is nice. I don't really like super loud ones. Okay, so we've got that. If we have list data equals null, so if this fails, error reporting, right? This is a out of memory error. We should probably do something there, but for now I'm just going to ignore it. Okay, but if we do this, we should be fine to just say list. We're going to do this. We'll do that, and then we can say data length equals, or actually no, we want to do this beforehand, right? So we're going to do this equals our element. That should copy it. Should copy it. What's wrong with this? Oh, we need to dereference it to copy it. We increase the size, and that should be good. Okay. And then we also want to say static void erase, and this will take in our list, and it will take in an element. Okay, so for erasing, what we're going to do is we're going to say for size t I equals 0 until I is less than length. If they're equal, we can go give that list plus I and element. We want to erase it. Doesn't like this because we need to say list data. Okay, so if they're equal, we need to erase the element here. To do that, what we can do is we can just say memcopy, and we're gonna put it here, okay? And what we're gonna give it is list data plus I plus 1, and the size is gonna be size of this times list length minus 1. Right, so we do that, and we're gonna say list length minus equals 1, break, or I guess return. Either one works. So yeah, that should erase it because it's just gonna copy everything to the end of it, over it. And what happens if, ooh, okay, and we also have to be careful here because, well, actually no, if this, so if length of the list is 1, this would be 1 minus 1 is 0, and if that's 0, then it's just gonna do nothing. Memcopy should handle that. Let's see, just make sure. C, memcopy, 0 size. Oh, and I should probably use memmove. So the answer is no, the check is not necessary. Yes, you can pass 0. Okay, cool. So we can pass 0 there, and we're actually gonna call memmove instead. Memmove, okay. And I guess we should do memmove s. So let's just redo this real quickly. Memmove. So we want to move data plus I. Our destination size is GMA debug memory allocation. Oh, and that's wrong. That should be that times list length minus 1. Okay, source is going to be list data plus I plus 1. And the source size is going to be the same thing. Let's just move this, right? So we do that, that, and that's going to be size of times list length -1. Okay. So we're going to move that to that, and I think that should handle it better. I'm not sure what memmove versus memcopy will do here, but I think memmove handles moving overlapping regions of memory better. So yeah, that should be good. Okay, so anyways, that should erase. We have erase now. We have push. And we do -=1 +=1. Okay, so we should be good there. So now when we go back to here, we have our list. We're going to do this. Okay, so then for init, we're going to say allocations dot data. Ooh, okay, and then we need to do a gma debug memory allocation list init. Give it allocations. Okay, so we're going to do that, and that should be fine. Right, we're just going to do that. Actually, we can just do that. Yeah, that should be good. Thank you for, SE Woods, thank you for donating $20, man. Didn't have to do that. The keyboard wasn't that expensive, so it's all good. But I appreciate it. Thank you. Let's go into here real quick. We're going to say void memory allocation list init. That's awesome, though. Thank you, man. Give it that. Okay, so we're going to say capacity. We're going to start off with 8 for no particular reason. And this is going to be malloc. Okay. And you just had to test if the message got attached. Did the message get attached? Oh, okay. You said $20 wasn't more than this. I see the message now. I don't think the message pops up on the actual screen. So I have to start looking at the actual message in my mini feed, which is up here. Was it more than this? Yes. Okay. Now we know. Okay. And now I know how to see the message. So thank you, though. I appreciate it. That's awesome. Let's go ahead. So this should initialize our allocations to 0 and give us an initial size. You saw the message, tiny letters below the donation. Okay, so the message does go below the donation too. I'm going to actually have to start paying attention to those things because it's kind of hard to see on my screen, but I do appreciate it. So we're going to give this that. Okay, so we give it that. That's good. Then we're going to say push temp. Okay. And that should do what we want. Finally. Okay. And since this is returning a reference to the actual element, what we do is, this is what? This is allocate? Yeah, so otherwise, if we already have a reference to it, I just increase the references. Oh, this is if the references is less than or equal to 0. Okay, so this is if we've already encountered this piece of memory before, but there is no longer any references to it. And then otherwise, I error out that you tried to allocate memory that was already allocated. So you allocated over a pointer, which should never happen. So should never be hit. Yeah. Okay. So otherwise, if that all succeeds, then we just return that. And if we're not tracking memory allocations, we just return malloc. So realloc, and this has some problems that we'll try and fix real quickly too. Okay, so this is going to be old memory iter, which is going to be gma debug allocation find. Okay, just move that to a new line. We're gonna give it reference there. I guess technically, well, let's go ahead. We're gonna do this. Temp equals that. And we're gonna give it temp. Okay. So we get temp if the old memory is equal to null. Okay, this is fine. So if old memory was null, so right now I have that as an error, but technically if you realloc with null, then what that means is just return an allocation. So what I should have done here, which was stupid on my part and it was really annoying, so I'm finally fixing this. This should return gmemory alloc or allocate line number bytes. Okay, so that's what that should do. And I'm gonna go ahead and fix that up in the C++ implementation too, because this is really annoying and I should have fixed it a long time ago. So let's go ahead and fix this. Realloc, if this happens, we do that. And that should fix everything. Okay, that makes me happy. Cool, so we got that. That's good. Why does this not like temp? Const allocation. Oh, this should be GMA. Okay. That's better. Cool, so we fixed that. Otherwise, I copy, so this is a Sentinel copy. Okay, so I call it Canary. We're calling it Sentinel now. The code is consistent. I think it all calls it Sentinel. So we do a mem copy. Do we have mem copy S? We do. I should use that. So let's do that. Mem copy S. So destination is Sentinel. Copy. Destination size is size of uint8 times buffer padding. Okay. Source is this guy. And source copy is this guy. Okay. So that should do the same thing. I'm doing a lot of stuff here. Okay, so this is like the realloc version, and what I have to do is I just have to copy the data, and since I have Sentinel values, it looks like I'm copying those Sentinel values over. And then I'm just reallocating that whole memory block, is what it looks like I'm doing here. Wait, right? Okay. Yes. Okay, so I'm just adding this to the memory that was passed in. Okay. But this doesn't happen if you debug without tracking memory allocations, so it's fine. You don't get that added stuff there. So then we get new memory, which is where we realloc. Okay, and then I copy the Sentinel values over to that. Let's change this to mem copy safe. Right, okay, so uint 8 star, new memory. Right, we doing the same thing there. And then that's gonna be size of uint 8 times buffer padding. Or at least it should. Actually, I'm gonna leave this for now because I'm not quite sure what this should do. We're gonna use mem copy S here because I'm not sure what exactly we should be doing there. Then we free the old copy. So we free that. Here, add multi-threading safety and C. Okay, we're gonna change this. Let's grab that. Grab that, temp equals that, there. We're gonna go ahead and just change that to that. And then debug memory allocation find, or I guess, yeah, find. And we're gonna give it our list and our value. And we've got that. So I've got some extra stuff here. And I'm just gonna assume it's all right, and I'll debug this a little bit more later on. Okay, so this should just push it back. Do that. And then we're gonna go ahead and just change this to that. Okay, there we go. Should do the same thing. And this should all work out, hopefully. Okay, and then if we're not doing any of this, we just return that. Okay, so that's a complicated one. I don't like realloc. There's a lot of extra stuff that has to go on in there, which is not very fun. But hopefully it all just works out. Famous last words. To do, add multi-threading safety in the C. Okay. So same thing here. Go ahead and do that. With that. Temp equals that. Do that. Do that. All right, we got that. If this is null, we tried to free invalid memory. Double free if we tried to free it twice. Voxrifs, what'd you miss? Still working on translating this to C, which I guess is a good start. Gets me into a C mindset, right? Okay, so otherwise, if we have references is equal to 0, we're gonna go through our buffer padding. Okay, so this is where we basically just check to see if we have any heap corruption. This should be that. All right, that's fine. And same thing here. Okay, and that should check for heap corruption, and then otherwise, if everything went fine, we just free. Okay, G memory dump memory leaks. Let's go ahead and add threading safety to C impl. Okay, so for, yeah, we want to do for size t I equals 0 till I is less than length I plus plus. Why does it not like that? Allocations. Oh, because this is just that. Okay. And then we can say that, that, and then I just want to go ahead and do that, that. I'm wondering why I have this memory size minus 10. I think this might be off. I'll have to double check that. To do, should memory size minus 10 be, I think that's what it should be. I'll have to double check that. Okay, so this right now just does that. This just does that, and this just does that. The reason I have these implemented anyways is because eventually I think it'd be cool to add some extra stuff in here to make sure that this is valid memory. Well, I don't know. I don't know why I have this, just in case I ever want to change things up, I guess. Okay, so that's that. Now we have to fix the logging implementation, which is a lot of other stuff because there's string manipulation here. So that's going to be fun. But once we get this done, that should be it. I'm not going to worry about Linux for now. Okay, so hash if define use CPP. CPP win32 impl logging impl. Okay, can do that. Wait a second, what are we doing here? Okay, we got that. Yeah, I think we just want to go down here until we get to here. Okay. This is end, hash else end. Okay. So then this is C logging. And we shouldn't have use CPP defined right now. I wonder why that is defined. Oh, this should be hash if use CPP. There we go. So that's better. Okay, and then we're gonna copy that. This is our C implementation, which I'm just gonna go ahead and copy this so that I can actually see where I'm going and stuff. Okay, so. Okay, we got that. Why is it not happy with this? Oh, I need an end diff. Okay. So we got that. This is C11. Okay. And then I need an end if apparently. So if define win32 and if. Okay. And this, we're just going to change to that. Okay. I think this should be fine, possibly. No, this is probably going to be bad. I'm going to have to change the way this is working. Why is this? Linux is not defined. So I don't know why it's showing that this is defined. Okay, anyways, we'll continue that in a minute. Oh, I'm missing an end if here. That's what's happening. Yeah, okay. So we got this. And then we got that. Let me just make sure I've got all this right, because this is all kind of jumbled together, which I don't like. So we've got this. Okay. I've got to undo a little bit. So first of all, let's go back. Sorry this stream is so scattered too, guys. Hopefully it's still useful. I don't know how useful this is. Porting this to C is not particularly interesting, in my opinion. So, okay, let's go ahead. We're going to fix all this. Okay, so we've got C11 implementation there. Cool. So now we've got this. So it looks like what I did was these are things that are common to all operating systems. So I didn't do anything special. Then I have operating system specific stuff. And I don't know if that really matters too much. So let's call this, we're going to call this common. And then this stuff is going to be OS specific. Okay. And this is C++. Okay. Let me just make sure I did this right too now, because I am concerned. Okay, and this is not, there's no operating system specific stuff for that, which is why I didn't have to worry about anything. Okay, makes sense now. You recommend indenting preprocessor statements too? Yes, that's probably a good idea. And SE Woods, I think we're all here waiting for Crumble release LAN party. That's true. Eventually we'll get back to that, hopefully. at some point. Eventually, yeah. Okay, so this is gonna be C++. So if define, or if we do that, and let me just do that. Okay, so that's all that stuff. Hash else and if. Okay, so the reason I'm not indenting is because these should all be single level indents. I don't like indented multi or preprocessor statements, so that's where I think I've gone wrong here. Okay, whoops, that's not what I meant to do. Okay, so no, I did not mean to do that again. So we've got this. Let's copy this. This is going to be our C implementation. And common logging impl C++. Okay, we got that. And common logging impl C11. Okay. And this is the C11. So let's do this first. To do, add multi-threading safety to C. Okay, so we've got this. Can we do this in C? Is this how? Yeah, enums work the same way, right? Can we assign them to? Yeah, I think the only thing I just couldn't do this. I can't do an enum class, which is fine by me. Okay, so we should be good there. Well, you don't indent the entire line. You only indent the part after the hash. Oh, that makes sense too. I'll have to start doing that. Okay, so we have glogger level, which is initially all. We have a file star, which is initially null. Null. Okay, so that takes in a glogger level. We just set the log level there. We can return it too if you want it for whatever reason. Okay, this initializes that to null, initializes that to null, initializes that to all. I guess it's kind of redundant since we already have it initialized here, but whatever. Okay, so for free, we close the file if we can, then set it to null. We free the file path if we can and set it to null. Okay, if we set the directory, so this is where it kind of gets like operating independent stuff and all sorts of weird things. Yeah. Voxel don't play around. So this is where it's just annoying to do this type of stuff in C. So for instance, I want to get the time. Yeah, that's all annoying. Also, I need to do string manipulation. Very annoying. So yeah, let's see. That takes a TM star and a const time T star. Okay, so let's call this time T now. And let's see. C, get time now. So we have a TM star, time info, time, raw time. Okay, so I guess we just do now. Okay, so that's pretty easy. Now, why do I have this one? So that takes a TM star, which is what this is, struct TM. And we should call this something else, local time. And then it takes a time T star. Okay, so now we're converting from that to that. Okay, so we're converting from whatever that is to our local system time. Then we need to string format time. Okay, so this is where I think it gets annoying too. What does this do? ASC time. C, string format time. Actually, I think this is a C function. I think if I just get rid of stood. Yeah, okay, we're good there. Give it local time. Okay, so now what this is gonna do is it's going to put everything, it's going to put log, year, month, day, I think that's hour, minute, second, .txt. It's going to put that into this time buffer. Okay, so now we want to do string length and that. Okay. Let's throw in a slash in there. So if the directory string length is too long, then I just print an error. Okay, then I malloc, because I can't use my allocation library with this stuff. Looking forward to when Gabe creates his own emojis collection like the one you just posted. I really got to get into all that type of stuff at some point. Sometime, hopefully. Okay, I really want to get this done so that I can just move on to the actual project now. I wasn't expecting to have to do this. Okay, so if not log file path, we failed to allocate memory. Okay, so I actually do return for memory allocation failures here, which is interesting. So what? So I allocate size of char times file name length plus the directory string length. Okay, so we do the directory because we're appending it. Okay, so we directory plus the file name length plus 1 for null byte. Then we copy that to our buffer here. We copy that to the buffer. And then we add a null byte. Then I open it finally. And then if we didn't open it, then I do that and we free it. And we do that. Okay, so that initialization was all pretty much C, which is good. Now for the hard part, which is going to be these things, which I did not really do it in a C style way, which is annoying. So this is going to be fun to do. C safety, C multi-threading safety. This is especially important in the logging too. Okay, so this is for Win32. Okay, so we print it, that stuff. We change the colors around and stuff. Okay, so we get time, which we're just gonna do, right? We do that. So we get now. We get local time. Okay, we do that. I guess I did do this in a C style way, which is good. Hopefully, I don't know how much of this is C style. Okay, then we do that. Do that. Oh, okay, I guess I did do this in C style. Cool, so this will be easier than I thought. Thank God for that. I'm glad I did this instead of doing it the hard way. Well, I guess this is the hard way. Instead of doing this the easy way, I guess I should say. I thought I used a bunch of stud string all over here, which is what I was anticipating having to do. Okay, so we do that. Do that. Okay, we do that. Did I do that too here? I think I passed. Okay, no, I did pass local time. Cool. Do that. That. Okay. We also put it in the file if we need to. Cool. That's all good. Okay. Hopefully I get the point at that time. Okay, we do that. Time now. Cool, we got that. We have a buffer. Local time. Okay, we do that. That. Local time. All good. Okay, that's all good. Same thing here. I think this is the last one. I guess this should be abstracted into a function since I'm doing like literally the same thing several times here. Because this is definitely not very safe. This is very error prone. But it is what it is. And hopefully I'm not going to have to update this anytime soon. So, got that. And then assertion, which is the final one. Okay, so the assertion is where I was using stud string. So this is where I'm going to hate myself. Multi-threading C impl. Yeah, so this is where it's going to get annoying. Okay, so the full error message. Why do I have this? And why do I have the carriage return there? Okay. So we need to change this to char. At this point, if you have an assertion error, I really don't care about memory allocation safety and stuff since you're crashing. So we're going to say our buffer, and we're going to give it like, that should be a 2. Okay, we're going to give it a lot of room. Okay, 4096 bytes. We should be good there. So then this, we're going to say, first of all, we need to add this critical assertion failure thing, right? Message 1. I don't know what the best way to do this in C would be. And I guess we should probably just do mem copy here. So destination is that, source is message 1, size is string length of message 1. Yeah, and that's all we want. And I'm actually gonna do mem copy s. Okay, so destination is that, size is times okay, we got that. Yeah, we got that. Okay, we got that. Cool. Source is message 1. Okay, we got that. That should be good. This is going to be 0. I guess, well, I guess we just do void star. Well, okay, here. You're going to do this too. Size t offset equals 0. And, oh, no, that's just complaining because that should say buffer. Okay. So we've got that. That's the first part of the message. Now we have to get the next part of the message. And we have to say offset plus equals. Let's do this. Okay, this is why I hate string concatenation. There has to be easier way. Voxriffs, I might have to take a look at your library that you've made, because I think you have some string stuff in there too, and that would be very helpful in this case. Let me just see. Voxriffs, you're doing all this without sprintf? Wait, okay, you should look into the arena scratch allocation, by the way. They make using C a lot nicer. Wait, what is sprintf? Okay. I think that's probably what I want to use. sprintf will help, maybe. Okay, I'm going to have to look into that. Thank you. Gabe making funny faces while YoMeister snaps photos. Is he here? I didn't see him. Uh-oh. I hope he's not snapping any photos. Thank you, Voxerus. Man, I didn't know sprintf. Ah, that makes so much more sense. Thank you. This is what happens when I don't actually learn C. This would have helped me so much more. Okay, so we give it our buffer, which in this case is our full error message buffer. We give it our buffer count. Okay, we give it that. We give it the format. Oh, Voxriffs. Dude, what was I thinking? Thank you so much. This is so much easier. I don't know what the heck I was thinking. Okay, so now I can say critical. It writes your formatted message to the buffer instead of the console. Yes, this, I have no idea what I was thinking. Thank you so much, because this makes it so much easier. Okay, so then we do %s for file name. Line. Okay, that assertion failure. And then the assertion failure. Okay, so then I have to do some more stuff too. Okay, which is fine. We'll get that in just a second. So anyways, though, for this, we do line. And I think that's the only thing. Oh, no, we have the file name. Line. Okay, so we do that first. Let's get rid of that. Okay, we still need offset because I think I'm gonna have to do some extra stuff, but thank you so much. This is way easier than all that garbage I was doing for absolutely no reason. Okay, so we got that. Offset equals string length of that. Okay. Now we get the time, and this is going to be so much easier now that I'm using the smart thing. Okay, we do that. Local time. Give it that. Give it that. That. Okay. Oh, and apparently I wasn't even doing that. Oh, no. I do want to print it, and then I also want to add it to our error message. Okay. So then this would be sprintf. Actually, yeah, we'll do sprintf s. Okay. Buffer is going to be full error message buffer plus offset. Full error format is going to be that. %s that. Oh, this is so much easier. I have no idea what I was thinking. Okay, and then that we're just going to give it buff. Okay. Got that. That's done. That's not that hard now. No semicolon there. Okay, and then I also need to do, what is this? Oh, this is just like the rest of the formatted strings. So let's do offset. Okay, we got that. So now we go here and sprintf s. Full error message buffer. Okay. Full error message buffer size and format, which is just %s /r/n. And that should be a string. Okay, there we go. That's better. And we're just going to give it our buffer. Oh, and semicolon there. Okay. And that's it. So much easier than what I was doing. That makes string concatenation so much better. I have, yeah, no idea what I was thinking there. Okay, cool. And then one more thing, I guess. If log file. Oh, and then I basically tell you where the log file is too. So let's also add this to our sprintf s. Error message buffer. And I have a bug here. That should be minus offset. Okay, did I do that? I did do that there. And we also want to say offset equals. And I have another bug. That should be plus offset. That's better. Is this plus offset? That is plus offset. Okay, plus offset, minus offset. That should be that. That should be that. Okay. Then we got /r/n. Located at %s log file path. Okay, and we got that. Semicolon. That's good. Okay, and then finally I can just do a message box, and instead of this, we give it that. And we're good. Cool. Okay, so that should be it. It should be now C-ified. Hopefully. We'll see. I guess testing time now, right? Thank you again, Voxers. Man, I cannot believe how stupid I was. Yeah, for real, for the win. That man is a wizard. I've always known it. With the Steve face. So have I gotten any vacation this summer? Yeah, I would say for sure. Like, I took 4 days off of work, or no, 3 days off of work earlier, and went to Gatlinburg, which is a nice, it's like in the Appalachian Mountains in America, and have some nice trails over there. I went on Gabe's Mountain, so I hiked my own mountain, I guess, which was pretty cool. Hopefully you guys have had some time off too and are taking breaks, which is always good. Let's also go into here very quickly. Okay, we got that. Okay. Vox riffs, yeah. I promised. It was actually called Gabe's Mountain. I was like, I've got to hike this now. It's got my name on it. And so I took a picture next to the trailhead sign and everything. It's pretty cool. Okay. That's undefined. Oh, and now all of a sudden this is undefined. Why is G logger level undefined? We got G logger level there. Ah, okay. It's because of this. Ooh, okay. We can't have defaults. We cannot have default stuff. Let's go ahead. Re-init. Let's go ahead and do that. Let's see. Why is this not happy? Bool is undefined. Oh, bool is not defined in C, is it? No, it's not. Wrong way. Right? You don't have bool in C. I don't think so. Oh, include std bool. Thank you. I was like, how do I get this? That makes it easier. Include std bool.h. Okay. That's better. So now we've got, that's fine. Expected semicolon. I'm guessing this is just waiting to catch up. Come on, IntelliSense, you got this. And as you would, nice, but 3 to 4 days. I'm talking about weeks. Oh man, I wish I could have weeks of vacation. That would be pretty cool. Unscoped enum stuff. Do I have unscoped enum stuff here? Why is it? It's not happy with this. CPP utils API. Oh, did I spell this wrong or something? Wait a second. Got that. Void. Okay, now it's going. IntelliSense is just being slow. Okay. We also have to fix this. Do I have to do a... I think I have to do a... Do you have to do this in C? We have to type def it? Yeah, I think I do. Okay. Well, at least Visual Studio IntelliSense is finally interpreting this as C now, which I guess is good. This is a list star. Why is that not happy? Do I have that typed differently? GMA underscore debug memory allocation list. Oh, yeah. It is finally interpreting this correctly. That is interesting. I wonder why it wasn't doing it correctly before. And now we can't use this too. Expression must have a constant value. So we just have to do... that, which I don't like too much, but should be good. Nope, you still don't like it? Expected a right bracket. Oh, no semicolon there. Okay, so we got that. That's good. Once again, I'm just very glad that's working. Can I now do dot file? Does that work? Can we do this? No, it still doesn't work. So it expects the initializer. I can't add that to prefix it, but I also can't do... Oh, wait, I can. Okay, cool. Oh, this makes me so happy. It's the small things, you know? This makes me very happy because now I can use this awesome feature, which C++ should have, dot line. This is a play of the game for sure, guys. Pog for sure with this guy. Okay, let's see. I don't know what the proper terminology and everything is. This is references. Yes, because now I actually know what I'm assigning here. Dot size equals that. And memory is that. Okay, this is amazing. Ah, okay. I've wanted to use this for so long. You have no idea. Let's go. I actually might have to... Let's do that. Just want to make sure that these are all the same. Okay, so file name, line 0, that, we're good there. Okay. Let's keep going. I guess it's a good thing I did this differently too. And the reason I'm doing this because like, look, that should be 1. So I knew there was a few line bytes. Okay, we're good there. And this should be called new alloc. Okay. And now this is here. Line references memory size is 0. Memory is memory. Okay, we got that. Scroll down. Okay. Glogger level all. It doesn't like this for some reason. Why not? Type name not allowed. Oh, I have to. Wait, okay. Do I have to type def this? I don't think I do. Do I have to do that? No? I'm doing C enums wrong, I think, right? Okay, wait a second. Let me see. Okay, include stood bool. Stood bool is a U8. Yes, so type def for bool and true 1 is false 0. Yes, you have to type def enum. Yeah, it should work. Compound literals for the wind. Yes, for the wind. That's the one I was looking for. Old memory was new memory. Oh, thank you. Wrong variable. Oh no, you have to use the name itself without the enum name. Oh, that's the only different thing. So we do type def this. It's just we have to do, so this is why IamGUI does this, isn't it? So we'll go change all that. You said old memory was new memory? I messed that up. I'm actually just going to undo so I can see where I messed up because I don't remember. Okay. So memory, file name, line 00 memory. Did I do that somewhere else? This should be new memory. Thank you. Okay, so that's what that should be. Okay. Now we'll keep going. Thank you, Voxerifs. I appreciate watching out for me like that. Let's go ahead. We're just going to do this. That. Dot file allocator equals that. This is references. Okay, we got that. Dot memory equals that. Okay. And now we go back up to here. So that's fine. I just need to change. Actually, it's not fine. I'm gonna change that. Go back here. Change that. Now that's fine. Okay. Does this actually have any type safety associated with it is what I'm curious about. But I guess it doesn't matter too much. Okay, we'll just change that. No const expr. Can still make that const. Actually, we have to do that. Unless I use it anywhere. Does C allow you to indent macros? Oh, that should be max path. Okay. No, so I need to keep this for a little bit longer. We have max path there. I'll just undefine it there. Okay, this should be null. See, man, I thought I had this as close to C as possible, and there's all these bugs popping up because C is actually very different from C++. Converting C++ to C is not as straightforward as you think it is. That's for sure. Okay, warning, which, yes, that is 3. Cool. Error. Assert. Looks like I did a pretty good job here at least. Okay, hash define that. And then we're going to have to undefine that. So let me copy that. I'll fix that in a minute. Okay, that's undefined there. Like, it really shouldn't matter where I put these two because macros are run before the code, so this doesn't have any scoping attached to it. This should be that, and we want to, same thing here. Okay. So buffer counts, those are undefined afterwards. Now we're good. Okay, is this going to work is the question. Oh, let's see. No, it's not. I'm going to see chat real quick with the same error. Wait, there were multiple places with the same error. When Gabe has an off day, his crew at the rescue. Yes, meanwhile, I quietly observe and provide off-topic disturbances, which are good too. I need those to like give my brain a rest for a second, you know. I may have to check your repo at this point. Oh yeah, I'm definitely gonna check it in just a second. Let's just go fix this real quickly. What's wrong? Oh, I did not mean to do that. Where's this coming from? Syntax error. Why is that a syntax error? Whoops, that's not what I meant to do. Oh man, see, I keep pressing the wrong keys. There's like keys on the side of this that mess with my brain. Okay. So I think what's happening here is if VA args is not defined, it doesn't like that. Is it possible to overload a macro? I don't think it is. Yeah. Which is unfortunate. Is that what's going wrong? Wait, let's just double check real quickly. So, yeah, because it's complaining here. And I think that's just because VA args is empty. If I were to add a dummy thing there, does that remove that line from the compilation error? main.c16. Yes, and then it moves on to there. Okay, this is very annoying. No, VA args adds an extra, I believe. There is some way to stop that. You don't remember exactly how. Wait, let's see. Okay. C VA args empty macro. Okay, variadic macros with 0 arguments. Okay, as for the update question, the use of the auxiliary macro VA args like the following, the arguments will be expanded as expected. Okay, when compiling for C99 or C11, it yields a warning. VA opt will be your friend. Do we have VA opt in here? Can I use VA opt? Let's try it. Let's go up to here. Do we have VA option? Let's try that. Oh, and I should probably change that to just C. Nope. VA opt is undefined. Okay. Oh, wait, I see what he's saying. Okay, so this definition, okay. We'll basically copy paste, comma. Let's try that out. Okay, so if I do that, and then we do this, Does that fix it? I really hope so. If it does, that's a really easy fix that I would have never thought of. Okay, let's see. No. Doesn't like it? Well, yeah, it doesn't like it. Expected an expression. Pound before VA args, basically. Well, he's got a comma there too. Oh, and he has no comma there. Oh, okay, okay. Yeah, I don't know if that stringify, like if the comma was important, but I think you're right, VoxRiffs. I don't think that the... No, it still doesn't like it though. Wait, okay, here we go. Cool. Thank you, that worked. Temp, redefinition. We're gonna call this temp 2. Let's call this new temp. The reason new is because this is the new memory editor, so new temp. I guess I could call the other one old temp, but it doesn't matter too much. Okay, so we got a breakpoint. Okay, well, this is good news so far. So we got a log with some information, warning, error, try to free memory that's already been freed. Okay, so I think that's good. And then it tells me the code that tried to free, line 25. Is that true? Okay, so we initialize, allocate. First of all, okay, so I allocate that. Okay, so this is a memory leak, is what that is. Some memory, we allocate size of char times 24. Then I free that. So that should be an underrun. Okay, so I think I've got a problem here. It says line 24, some memory, so it's this. Okay, so that's broken. We'll fix that in a minute. Heap corruption detected, buffer underrun, line 27. That is true. Okay, so we did have a buffer underrun there, which is very uncommon, but I have that anyways. Heap corruption, buffer overrun, line 31. Cool, that's true. And bad assertion should fail and break the program. Yeah, cool. So true works, false does not. Okay, cool. I'm pretty happy with that. We did not see a memory leak though. So two things. We didn't get our memory leak printed, and we did not get... it thinks that this is wrong. So there's a problem in our freeing code, which is here, there. Okay, so for tracking, we do that. And what did it say? It said, try to free memory that's already been freed is what it thought, which is interesting. Oh, if this does not equal null. Wait. Yeah, if it does not equal null, that means that we've found something. Okay, I think that's the only thing. So let's try that again. We've got memory leak detected. Okay, so yeah, that memory leak thing is definitely bad. Okay, this is also good. To do, I think, no, this. Let's go. Okay, to do, F3. Okay, yeah. So this was definitely true. That should be buffer padding times 2. Okay, let's try that again, because it was reporting the wrong number of bytes that was leaked. Okay, so now we got leak detected 543 bytes allocated from line 27. Is that true? 543 bytes allocated from line 27? Yes. No? Okay, that's wrong. Wait a second. Okay, so we free that. Something weird's going on. We should be seeing 1025 from line 22. Oh, I think I know what this is too. I think the realloc. Either realloc or a free implementation is broken. Okay, so what do we do here? We say that we look for it. Okay, if we find it, if it's 0, then I check for, oh, I never actually erased this, do I? I mean, technically it doesn't matter, but wait, no. Okay, it does matter. Okay. So the reason I don't erase this from our list is to detect double freeze. So I can't really pop that off of our list, but something weird is happening. Let's walk through this code very quickly. Okay. Let me just check chat real quick too. Maybe because of the old memory, new memory thing. Yeah, I'm wondering if that is. Also, once you join SE Woods Gaming, you can take vacation whenever you want. That sounds good to me. I'm going to have to consider that. Technically at my job right now, I have unlimited paid time off. So I could technically take vacation whenever I want, but I don't because I just do the work that I need to do. So yeah. Okay, so we've got that. We initialize. So popping into here, we do that, we do that. This sets our list. So then if we take a look at our allocations, we've got data. I should probably zero that out, but I think this is fine. Data is at some address, so that's okay. It's just weird because, yeah. So when we allocate, we do that. Okay, we actually allocate the memory. Okay, we add our padding. It's fine. So now if I were to go ahead and pop this guy into our watch window over here. Okay, so we get Hey Gabe, which is the Sentinel. Then we get the memory, which is zeroed. Or I guess it's not zeroed, it's just garbage. And then we get the Sentinel again. So that's all correct. Then we do this. Temp looks like it gives us the name, the line, the references, the size, which includes that buffer, and it gives us the address, which all looks correct. So then when we go into here, this is 0. Okay, so it returns null. So then we push it. List length +1, length is 0, max capacity is 8, so we should be fine there. We skip that. We pop this to the beginning of our list. Let's go ahead and add our list here so that we know. List data, we'll look at the first 10 entries. Okay, so now our first entry is, and you guys can't see this? Okay, good. So we get the file name, line number, and references, which is 0, and that. Okay, so we return that. Oh, should we have references there? Should that be 1? I believe that should be 1. That doesn't feel right, because now we have 1 reference to this, right? Okay, so let's look at the C++ version just to double check, because the C++ version is the old version. Allocate, we do this. 0 there. Ah, okay, that was stupid of me. So I am putting 1 there. I wonder if that's causing issues. I mean, it is clearly causing issues because it's broken. Let's do that. Let's see if we get it right now. Let's do that. Okay, warning. Okay, here we go. Now we get it. So memory leak detected 1025 bytes from line 22. Is that correct? Line 22, untracked memory. We should be warned. We are 1025 bytes. And we have memory leak detected, leak 543 bytes from 24. Ah, okay, so 543 bytes from 24. So problem with reallocating. Let's jump into reallocation, make sure that all looks right. So This stream was horribly mistitled too, so sorry for anyone who joined. I was expecting what this should arguably be about. Okay, so let's jump into here. But I'm still going to go and start that as soon as we finish this, which is almost done. So we got old memory, that's fine. Old memory iter, which we get, which should find something. So this finds, yep, main.c allocated from line 24, one reference. Okay. So then we go and we get sentinels, we copy the sentinels. Okay, we reallocate. The reallocation succeeds. So then we change the memory size. We copy the memory. Okay. Yeah, we copy the old sentinel values. That way we can still detect if there was a heap corruption in the old one or whatever. Okay, so now the new temp. I think I see the problem already. This should find something. We do find something. Reference is 1. Okay. So then we just return that. No, so this does look like it should be fine. We didn't push anything new. Oh, but maybe I should be... Oh, yeah, so this is like just if we've reallocated to a new block, then I decrease that reference count because it's essentially freed that. And then we push the new allocation. Okay, yeah, so this all looks fine. Yeah. Okay, so then when we free, okay, so we find an iterator. That's not null. We have one reference. So if we do this. Oh, that's wrong. Is this not equals null there too? Let's just check. Tried to free invalid memory. Ah, okay. So that's another problem. So this should be if it does equal null. And now we should be good. And now we should be good. Okay, so we got leak detected, 1025 bytes, buffer underrun, buffer overrun from line 31. And does that tell us that? Okay, cool. Yeah, I think that's, yeah. Good enough for me. Let's go ahead and push this and hopefully nothing breaks. So let's go get status. And actually I need to do also, do I still have this up here? Okay, yeah, so it looks like C++ is no longer defined too, which is interesting. I wonder why Visual Studio was kind of like off. Okay, anyways, that's fine. Add C support. Okay. There we go. So now that's done. Okay. Now we're going to go back into Emulator.